Hi, my name is Brandon Burke. Today I will be giving a brief demonstration on generating accurate flat patterns in Fibersim that are representative of the hand layup process. For this demonstration, I will start with a C-channel part that has already had its plies spliced based on the roll width of the material. I will open Fibersim and select the laminate. This displays the net and extended boundaries as well as the normal direction as indicated by the yellow arrow. This shows the direction the plies will be built out from the tool surface starting with ply 1. The rosette utilized in this part is a spine-based rosette. Spine-based rosettes are typically used on C-channel shapes such as aircraft stringers. The design intent is for the 0-degree direction to follow the part's spine. At any point of interest on the parent laminate surface, the 0 direction will be tangent to the rosette spine at the closest point. This laminate has 6 layers of 8 harness pre-preg material. Note that plies 20 through 50 have been spliced, and plies 10 and 60 did not require splicing because the material width was not exceeded in the 0 direction. I have already created the flat patterns using Fibersim's default settings. When you run producibility and generate the flat patterns, it will create this feature group in the part navigator, with each ply receiving its own sketch. Let's examine the first ply. The default settings are traditional simulation method, fiber spacing factor of 1, and standard propagation method. To replicate the expected manufacturing layup practice on this part, I will change the simulation method to curvature adaptive. I'll specify a cell size of a 1/2 inch and change the propagation method to 2curve. And the constraint type I'll leave at geodesic. When changing the propagation method from standard to 2curve, a yellow arrow appears around the ply's origin. This indicates the direction the ply is to be laid. The geodesic simulation method is generally used to simulate when a ply is smoothed by hand along a straight line, such as along the spine of an aircraft stringer or C-channel first, and then smoothed uniformly outward from that path. If I change the fiber angle from curve to 45, you'll note that it rotates 45 degrees, but that does not represent the condition at layup. I will change this back to 0 and run that extended producibility. I'll generate the flat pattern. The orange curve displayed is the old flat pattern, while the blue curve shows the new flat pattern. Note the orange curve is smaller and has some waviness to it, whereas the blue curve does not have any waviness and is representative of the model geometry. It's also a larger ply in this case. It is important to review your flat patterns to ensure the output represents the ply definition. There are many factors when it comes to the generation of flat patterns, so sometimes it takes experimenting with the simulation settings. If you have a laminate surface that was not created well and has some topology errors, it can be tricky to generate accurate flat patterns. The design checker tool in Fibersim can be used to check the topology, geometry, and design, which I will cover in another video. Let's examine the second ply. So click OK. I'll apply the same settings to this ply. Notice when I change the propagation method to 2 curve, the fiber angle from curve remains at the default of 0. If I change this to 45, the yellow arrow down here now represents the direction it will be laid up. I'll click OK. These simple knobs to turn in Fibersim allow for the simulation to accurately represent the conditions of the hand layup process for this part. Another input to be aware of is the location of your origin point. This affects the simulation and the output of the flat pattern. If this part or process specified to begin the layup on the flange, it would result in a different flat pattern that may not work if the layup was started on the web face of this C channel. The laser projection will show the orientation and origin of the ply for operators so they know where to begin. Now that I have demonstrated the settings I will use on this part, I'll show you how to implement these settings efficiently on multiple plies at once. You'll notice that all of my B plies have centralized origin points, but I know the operators will start these plies near the splice lines over here next to the adjacent ply. So I will right click, modify, and note the name, specified orientation, step, origin, direction, and extended boundaries all display different, which is expected. And the origin, we're going to change the geometry. Let's pick, there's great. And so all 4 of those plies now share the same origin point right there. We'll click OK. Fibersim makes it very easy to update many items at once. Next, I will select all 4 of the 45-degree plies and implement the settings I previously specified. Change this to curvature adaptive, and we'll specify a 1/2-inch cell size. Propagation method will change to 2 curve again, and we want this fiber angle from curve to be 45 so that these yellow arrows all reflect in the spine direction. I have gone ahead and updated the settings to all of the plies. At this point, in the manufacturing tab, this will tell you if your flat patterns are out of date, in which case all of mine are. So I will run the extended producibility one last time. And generate the new flat patterns. Now these are my final flat patterns that are ready to be exported. I would like to thank you for your time, and I hope that you found this content beneficial in generating accurate flat patterns in Fibersim based on the hand layup process.